Greetings all and welcome to part 7 of the Elliott Wave 101 course. If you haven't already subscribed to the channel then please do so, and in that way you don't miss out on any future updates as more material is published. If you found this video helpful then give it a like and don't forget to check out more course videos. So in this video we're going to take a look at the rules that govern the correct identification of triangle structures. So from the Elliott wave principle, a triangle appears to reflect a balance of forces, causing a sideways movement that is usually associated with decreasing volume and volatility. The triangle pattern contains 5 overlapping waves that subdivide 3, 3, 3, 3, 3 and are labelled A, B, C, D, E. The triangle is delineated by connecting the termination points of waves A and C and B and D. Wave E can undershoot or overshoot the AC line, and in fact our experience tells us that it happens more often than not. There are 3 varieties of triangles: contracting, barrier and expanding. Despite their sideways appearance, all triangles, including running triangles, affect a net retracement of the preceding wave at wave E's end. Most of the subwaves in a triangle are zigzags, but sometimes one of the subwaves, which is usually wave C, is more complex than the others and can take the shape of a multiple zigzag. A triangle always occurs in a position prior to the final actionary wave in the pattern of one larger degree, i.e. as wave 4 of an impulse, wave B in an ABC, or the final wave X in a double or triple zigzag or combination, which we'll cover in future videos. So a few visual points first. So for any of you that are familiar with basic technical analysis, when you see this formation, you would automatically think, oh, it's a flag, it's a wedge, it's a pennant, something along those lines. In Elliott wave we consider this to be a triangle. So the basic premise is the same in so much as we all observe price shrinking in a contracting range and we're waiting for the breakout. The main difference is the Elliottician would consider this formation in relation to the overall structure and thus would try to anticipate what comes next. Here we have both a normal contracting triangle and a running triangle. So a few things to note here. The Elliott wave principle notes that wave E can finish in either an overshoot or an undershoot of the AC trend line. The Elliott wave principle also notes that this is quite a regular occurrence. So for presentation, I've depicted all the example triangles with wave E neatly pivoting off this trend line. But sadly the market seldom gives us that clean end that we're all looking for. So remember that wave E can finish anywhere as long as it doesn't finish lower than the end of wave C. So in a running triangle, wave B goes beyond the start of wave A. And that's the same sort of thing that can happen in a flat. So there's no rule that prohibits this, with the exception of the 150% rule, which we'll cover shortly. So first we'll have a look at the rules regarding a contracting triangle, which is the most common triangle you'll find. So a triangle always subdivides into 5 waves. At least 4 waves amongst A, B, C, D and E each subdivide into a zigzag or a zigzag combination. And once again, we'll cover that in future videos. Wave C never moves beyond the end of wave A, wave D never moves beyond the end of wave B, and wave E never moves beyond the end of wave C. The result is that going forward in time, a line connecting the ends of wave B and D converges with a line connecting the ends of waves A and C. A triangle never has more than one complex subwave, in which case it is always a zigzag or a combination or a triangle. So let's visualize this, and rule 1 states that a triangle always subdivides into 5 waves. Wave 2 states that at least 4 waves among waves A, B, C, D and E each subdivide into a zigzag or a zigzag combination. So you can see down the bottom here I've just included a quote. Most of the subwaves in a triangle are zigzags, but sometimes one of the subwaves, usually wave C, is more complex than the others and can take the shape of a multiple zigzag. So we haven't got into combinations yet, that's coming up soon, but you can see here basic zigzags going in for wave A and wave B. When we come to wave C, we've got a multiple zigzag, as in we've got what we would call a double zigzag. So we have one zigzag here and we have one zigzag here. They are intersected by a corrective pattern, in this case another zigzag, but this is a complex correction. The rest of the corrections are simple in so much as they are straight out zigzags. Rule 3 states that wave C never moves beyond the end of wave A, wave D never moves beyond the end of wave B, and wave E never moves beyond the end of wave C. The result is that going forward in time, a line connecting the ends of waves B and D converges with a line connecting the ends of waves A and C. So that should be pretty obvious, as if those lines don't converge, we don't have that wedging in contracting pattern. Rule 4 states that a triangle never has more than one complex subwave, in which case it is always a zigzag combination or a triangle. So you can see here, as this example we had before, in wave C we have a complex correction. In this example here, we have a complex correction in wave A and C, so this would not be allowed under the rules of Elliott wave. So now we'll look at barrier triangles, and a barrier triangle has the same characteristics as a contracting triangle, except that waves B and D end at essentially the same level. We have yet to observe a 9-wave barrier triangle, implying that this form may not extend. I'll leave that with you. When wave 5 follows a triangle, it is typically either a brief rapid movement or an exceptionally long extension. So let's visualize that. So the first rule, a barrier triangle has the same characteristics as a contracting triangle, except that waves B and D end at essentially the same level. So what we effectively get here is a double top with B and D, and then the AC trend line converges in, so you get a barrier in the market, a price barrier. Now the second note here is that when wave 5 follows a triangle, it is typically either a brief rapid movement or an exceptionally long extension. So we see this isn't just about barrier triangles, it's pretty much for all triangles, is that when we see a triangle, we expect wave 5 to be quite sharp and quick, and then run out of gas pretty quickly, or failing that, we'll get a very long extended fifth wave. So that's it's almost along the lines of guidelines rather than rules, but we'll get to guidelines in future videos. So finally, we'll take a look at expanding triangles. So most rules are the same as for contracting triangles, with these differences. Waves C, D, and E each move beyond the end of the preceding same directional subwave. The result is that going forward in time, a line connecting the ends of waves B and D diverges from a line connecting the ends of waves A and C. Subwaves B, C, and D each retrace at least 100%, but no more than 150% of the preceding subwave. So this is an expanding triangle, and as the name suggests, the lines are expanding rather than contracting, so the trend lines are diverging, and the only rules is that each swing must go further than the last. So subwaves B, C, and D each retrace at least 100%, but no more than 150% of the preceding subwave. That means in this example, the wave from B to C, so the C wave, and then we have got the D wave, which comes up more than 150% the length of the C wave. So that's a no-no. That would break the rules under Elliott's rule set. So stay tuned for the next video, where we will take a closer look at combinations. Thanks for watching.